So welcome to the last talk of the day. So yes, I'm Bartosz. I'll be talking about custom printed OSM maps. Now, printed maps certainly is a topic that has been done before. It's my first state of the map, but my understanding is there will be a talk about this at every state of the map. But we believe we have a somewhat different approach to this because we really we focus here on custom printed documents, and our focus is on automation. So it's not about making the maps as beautiful, even though we care about that. It's about making this as easy as possible, and then we can go out into the broad world of creating as many of those custom maps as we can. Now, because it's about printed maps, you will see them on the screen, but they probably won't look very nice. So I actually brought some copies of what we produce here, hard copies. So you're welcome to drop by and have a look at them. So now, we focus right now on public transport because this is our first application. However, it is an idea that extends way beyond that as well. So, thinking about public transport for a moment, if you come to a bus stop or a tram stop, I'll just be talking about buses here for simplicity, you expect to find certain information. Ideally, you will want to have a schedule that will tell you when the next bus is due. You would want a strip map, which shows you where this bus is going, stop by stop, and where you might want to change into at that stop. And it would be ideal if you could also get a geographical map that shows you the bus route in the context of the entire city. The reality looks quite different. You will often not have this information for a variety of reasons. One is poor presentation. You will find layouts that are so hard to read that you spend most of the time trying to decipher what you're being presented rather than actually finding out when your next bus is coming. You will find partial information, so not all of this ideal picture will be on the ground. Most often you will find that the geographical map is missing for a number of reasons. One of them certainly is licensing. People use commercial maps, they have to pay, so they would rather not put it up. It costs them money. Another important issue is outdated information. Very frequently, this whole information is put up and then schedules change, bus routes change, but what you find at the bus stop is still up to date as of a couple months ago. And one important reason for this is expensive updates, specifically manual updates. We found as we were working on this project that very often what you have at bus stops is actually manually assembled from some kind of data sources. And so when there's an update due, it actually takes a lot of manual labor, and this just won't be done because it costs you so much. So I will first start with a few examples of what I've seen on the ground and what motivated our work. It's all Italian because I happen to be in living in Italy, but that doesn't mean that the Italians are particularly bad. It's just examples I have. Now, here's a bus schedule from Turin. The information presented here is actually quite complete and it's quite good. The layout is not very beautiful, but really, as long as the information is there, it's fine. However, there's a problem. It's flexibility. You see here highlighted in orange that throughout the day you will only get the minutes between individual bus intervals. Now that works okay, like there's intervals of 6 or 7 minutes between buses. Sorry about that. 6 or 7 minutes between buses. You don't really need specific times. But it's not so nice on the weekends when you have up to 21 minutes between buses. You don't really know when the next bus is due. You might be waiting that long. So certainly an issue here is flexibility. You would want a layout that lets you just change that for the Sunday, show them differently as Monday through Friday. Now, this is Milan, where they have implemented our idea, basically, without knowing that we had the same idea. So they have intervals up to 11 minutes, and on other days where you have 15-minute intervals, they will actually have listed the specific times, so that's good. However, you can see here one of the problems with doing things manually. What I've highlighted here, if you look at the orange boxes, at 7 p.m. on working days, there's so many buses that they just didn't fit anymore. They had to squeeze them, they made them smaller. Someone clearly manually adjusted the font size because it actually cuts off at the end of the line here. They just couldn't fit all the information in there. So it's manually adjusted, and it also doesn't present you all the information you want. Certainly it's not ideal. Now, strip maps can also be done quite wrongly. We're back in Turin again. This is the strip maps we have there. They're put up on huge signs, so they take a lot of real estate, but they don't really present you much information. The problem number one being that you have some stop names, but you don't really know what you can change into at each of these stops. That's not ideal. Another very curious thing in Turin is that these stop maps actually go from bottom to top. Which is actually the opposite of what's done pretty much anywhere else in the world. So I've seen even locals very confused about which direction the next stop is because someone decided to invert that. So that's a specific Turin problem. Here's a strip map that you will find in Genova. This at first sight looks actually very, very decent. It has a lot of information presented nicely, but also this one has problems. One of them is the stops that are behind your one, so like that the bus has already passed, are not marked in any specific way. So as you take your bus, you're not really interested in 2 stops ago. You're interested only in 2 stops from now. So rather than graying them out or marking them somehow, they just have them appear in the same font. It makes it less legible. But the main problem here is in the orange box at this point. What happens here is that at each stop, you have some numbers listed, or at some of the stops. Intuitively, and what you will be used to from other cities is, oh, right, these are the numbers of different buses I can change into at each of these stops. Well, that's what you think, but that's wrong. What they presented here is points of interest. They have numbered them and put them up at the stops, at each stop, which points of interest might be there. The idea is nice, certainly, and it's valuable information if you're a tourist. However, the way it's presented, it's quite hard to follow. It's again going kind of against the international best practice that you will find in other cities. So it's only confusing. Maybe someone has power for this thing? Otherwise, we'll have no presentation very quickly. I have my own laptop otherwise. So, yeah, that's strip maps and schedules. What can go wrong there? Maps. Now, geographical maps really are not frequently found at bus stops. You're finding... Oh, well. Yeah, it's gone. Oh. Yes. Okay. It's okay, gives everyone time to get into the room. Okay, I can continue talking about it. You'll see the picture in a moment. So geographical maps are very useful. They show you where the route is going. They let you find out within a maybe unfamiliar city where this bus is headed. If the names don't tell you anything really, you just want to see it on the picture. Now, the example that's on the slide that you can't see is from Milan, where they have...
There's people coming in anyway.
Yep. Where they have a strip map and a geographical map, and they have gone out of their way to try and arrange it so that the two align. The idea was nice. Unfortunately, it doesn't really work very well in practice, because the route doesn't just take a straight line to the city. It actually is U-shaped. So to make it fit onto a map, they actually have 3 separate pieces of geographical map that they have arranged underneath the strip map. And you have to actually puzzle them together in your head. And also they are not facing north, they are rotated, and there's only a small little picture in the corner of that printout that tells you how they belong together. So that makes it, again, quite confusing and difficult to follow, especially if you're not familiar with the city. And I believe we'll have a presentation in a second. So before I move on to the next slide, it would be nice if you could see that one.
Yep, just wait. It's
yep. Okay, I'm sure I can fill the time with talking a bit about it. Anyway, so the next slides that I will be talking about in a second is kind of what we do now and how we believe we can do it better. So the main point of our work is that we combine data that comes from another source that's authoritative on a particular subject with OSM. And in the case of public transport, we actually look at data from the public transport operator, who will be running the bus routes, and so they will know very well where the bus route is going. So they know the stops one by one. They will know when it's going, so they will have schedules, very detailed ones. And quite likely they will have a very good idea of what bus route you can change to at each stop. Even if the bus route maybe doesn't stop at the very same stop, but there's a 10-meter walk, they will have this information, and this information tends to be authoritative and complete, so we can use it from that source. And we can also look at OpenStreetMap, what kind of data we find there. And in OpenStreetMap, we'll get geographical data for the same bus routes. So we can combine the two to get a more complete picture, and then we can use our toolchain that we have developed to actually produce printed documents that will show all of this in a way that we believe is very easy to pass, very easy to look at, can be just printed out and put up at the bus stops. Oh, it's getting there. Yeah, top one. Very top. That's me.
No, do you have it? No. No. But where is it running? There we are. Okay, sorry for this. Now it should work again.
Okay. We just have to fly through the first few slides. Well, actually, for people who came late, I can just skip through them. Or can I just skip ahead? Okay. Oh, okay. I have to space through this. Right. So these are some of the examples of things that could go wrong with the information presented at bus and tram stops or public transport. Yeah. So this was the one I was talking about while we were blacked out. There's a strip map and a geographical map aligned with each other, but because the geographical map does not really follow a straight line, this is 3 individual pieces of map that you have to piece together and rotate into place in your head, and there's only a little picture that will assist you in doing that. Oh yeah, I forgot, I have another example of a map that actually works really well. This is from the Turin Metro. It's beautiful because it shows you all the nearby bus and tram routes and shows you where the stops are. The problem with this one is it's manually made, so the updating cost is prohibitive if you had thousands of stops that you want to make these for, and the bus routes keep constantly changing. Certainly in Turin they change all the time, so you would have to be remaking those manually. That's just too much effort. It's, we have in Turin quite a lot of maps that date back, or information that dates back to 2009, probably for that very reason. So yeah, I was talking about this. The transport operator has information about their stops and about their routes. They have operational details such as schedules, and they have a whole transport network, and they have this information. In OSM, we also have public transport stops and routes. We can tag them, and we'll have geographical details, and we'll have a geographical context, so a map and the routes in this map. Now, the data that the public transport operator has is updated infrequently whenever they change a schedule or route, whereas OSM obviously is continuously updated. So we have those 2 data sources. We'll have to try and combine them and to present this nicely. Now, the presentation we strive for is printed A4 pages, as I have up here, and you're welcome to a copy of this. And we want these to provide pretty much everything we can think of could be useful to you. So that's a schedule of the bus, that's a strip map showing where it's going, an overview map, which is a geographical map showing the route in the context of the city, and a close-up map that will show you other nearby routes and a map of the neighborhood so you know where you can walk from here. We use data both from the public transport operator and OSM, and we combine them. So this is all driven by changes to the operator data. So whenever something changes in the transport operator's database, they update the data source and they run the script to generate fresh printouts. And automatically, the most current OSM data is incorporated. And the keyword automatic is really important here. So we produce those placards that are printed and put up at the bus stops, and we produce them automatically. So as opposed to many other projects working on printed maps with OSM, we do not want manual map layout. We do not want any manual selection of the regions to show at each bus stop. That's tedious. We don't want that. We don't want any manual input at all. So the gain we have is fast and inexpensive updates. At the press of a button, you get fresh, nice printouts. Of course, the problem with this is that it has to be very robust and very good because there's no potential to fix anything manually. We have some components that use only one data source, such as the schedule, it comes directly from the transport operator. And we have other components that combine the 2. Those are the more interesting ones, like the strip map and our maps, our geographical maps that overlay one data source on the other. And now here's an example of what our results look like. I hope this will go to the next page. Sorry, forgot this one. Yeah, so our 2 data sources. The transport operator provides us with schedules, the bus schedules, and the correspondences. What can I change into at each stop? From OSM, we get the ways along each route. So we have geographical information, we have the stop locations, we have the stop attributes, such as tactile paving, such as maybe there's a shelter or a bench. We have names for the bus stops and their references. Both the transport operator and OSM will have those. We found in our work that the transport operator will provide us very creative misspellings, abbreviations that don't necessarily look nice in a printout. So we have chosen to use the ones from OSM, overriding the ones coming from the public transport operator. And in both data sources, we will have an operator tag, we will have a route reference, a number, and a stop reference. And these 2 are identical keys, and they allow us to actually combine these 2 data sets uniquely. So this is what we use to fuse the data from 2 different sources. This is the result. Again, I have printed copies of that because it's probably hard to read on the screen there. Now, a few components here are not so exciting, so I will just highlight that they are there but not talk about them in detail. At the top, we have the number of the bus route, where it's going to and where it's coming from. That's fairly obvious. At the bottom, we have the schedule. We really just pass the data that the public transport operator provides and produce this table. Of course, since we're using OSM data, we have proper attribution. That's obviously required, and it's there. Now, this component here is where the interesting stuff happens. We have a combination of OSM and public transport operator data producing two maps, the overview map and the close-up map, and our strip map. So I will zoom in. The close-up map shows an area around the bus stop, and it shows the other routes passing through here and the current route that you're on. Now, I'm certainly no graphical designer, so this could be improved, and it's kind of hard to read on the screen, but basically you see the current route in red, other routes in blue, and it all can be styled very easily. It's standard Mapnik, so you can absolutely go out and use any Mapnik tools you want to style this up in the way that you want to have it appear. We have an overview map which shows the entire route. This is bus and tram route number 10 in Turin. We have the current stop highlighted with a red circle. We have future stops, so the ones still ahead of you in red. And we have the ones behind you in gray, so you know exactly in which direction this is headed and which stops are already passed. And we have this strip map, which shows a lot of information coming from two different sources combined. So we have the bus stops. We have the past ones in gray. Those are not very interesting. We have the current one highlighted, obviously, and then the future ones in black. We have their names and references. Those come from OSM in our case. Correspondences, other bus routes you may change into. We're using data from the public transport operator here. And features of the bus stops, which the public transport operator does not provide us with, so we use OSM. And we have three symbols here. Again, I've designed them. They might not be very legible, can be interchanged easily. We have a symbol for blind, so that's tactile pavement. We have a symbol showing whether there's a bench at the stop, and another symbol showing whether there's a shelter in case it rains. And all of this now is generated by a toolchain, which is the core of my talk, how this toolchain is built. And it's all based on open source software, so it's purely free software, combined into basically 8 stages. The top 3 that you see above the dashed line are preparation. They are a pre-processing step that we have to run once, and then we can run the next 5 stages for every single bus route to get new printed placards for it. So some of these stages, or basically just one, operates only on operator data. It does some pre-processing on the data we get from the public transport operator. A number of stages look at OSM data only, using standard OSM tools mostly, scripted together with Python. And then we have a couple of stages that combine operator and OSM data to produce the actual printouts that we're interested in. And so I'll be looking at each stage one by one and showing you what they do. So the first one does some pre-processing on the public transport operator data. We get the data in GTFS format. This has become a bit of a standard. It was pioneered by Google. It used to stand for Google Transit Feed Specification, I believe. It came about with Google Transport or Google Transit, whatever their product is called. It now stands for General Transit Feed Specification. It's a collection of CSV files, and it allows a public transport operator to describe their routes and stops and their schedules. From this, we extract information using Python and store it in an SQLite database. We want for each route the stops, we want the schedules at these stops, and we want the corresponding routes you might be able to change into. Then we pre-process the OSM data. There are 2 separate stages here running in parallel, one using osmosis, the other OSM to PG-SQL. The osmosis run extracts information very simply, just with a simple query, to get us the public transport data out. What we are interested in is the route relations and the stop nodes. And the route relations, of course, we want them complete, so we want them with the ways and the nodes that they reference. We use the OSM standard public transport tagging schema to locate the data we want, and we rely on the OSM operator tag to find data that fits the operator for whom we are generating those placards. In parallel to this, we import the data into a standard PostgreSQL database for Mapnik rendering. There's absolutely no customization required here. It's a standard OSM to PG-SQL, standard database schema, and we just get information from Mapnik rendering. Once we have done this now, we have the pre-processing complete, and we can just start with any bus route and produce printed placards for it. The first step is XML transformation. First, osmosis is run, and then we transform the resulting XML into a format that's easier to parse for us. And we extract for this particular route that we're interested in now, its location, its stop locations, for each stop the name, the reference number, and 3 attributes that we visualize, which is the bench, whether it's present, a shelter, whether it's present, and whether there's tactile paving. Once we have this list, we can use that to drive, for example, the strip map generation. In parallel to this, we classify ways. What I mean by that is that we look at the ways that public transport routes go through, and we look for each of those ways, which routes look through it, so that we can concatenate their references. So if there's, say, a way that bus route 5 and 7 pass through, we want 5,7, so we can visualize it nicely. And also we want to find the ways that the current route passes through, so we can highlight them. We take this information and we store it again in a PostgreSQL database using OSM to PG SQL. We use the same standard database schema so that we can use mapnik to evaluate this and draw it straight into the map. At this point, we have all the data that we really need in the databases, and we can start generating things. So we run mapnik to produce our maps, and we use Python to drive it, a Python script, which of course mapnik likes Python. It has a very nice Python interface. An important point for us is that we want SVG. So bitmaps are not very nice for printing. You will have high DPI output. You might have variable DPI as it's printed on different printers. You don't really want bitmaps. So we were early adopters of mapnik too, actually, because it is much better at dealing with SVG. We produce a number of different SVG files. A single SVG overview map just gives us the whole route in the city. Now we take the bounding box of that route to produce the map without manual input of which map region do we need. Then for each stop, we have a close-up map, which is also an SVG file, and which, again, we can produce automatically because we have the stop location. So we know a neighborhood around this stop, and we produce a little map for that area. We can now use the data that we have imported into PostgreSQL to show other routes. I think I show them in blue and the current one in red, but certainly this is entirely flexible. You can style it as you wish. So we produce one of these maps per stop. And then we also produce these overlays that will let us show the stops on the overview map, wherever the current stop is, previous ones in gray, later ones in red. This is just SVG overlay files. We create those and we store them away for the moment because there's one more preparatory step, which is another Python script that combines for us the data that we got from the public transport operator with the data that we got from OSM. And what we do is, for each individual stop, we need to combine the two sources. We want the schedule that we get from the operator. We want to have the corresponding bus routes, which again we get from the operator. And then we want data that we get from OSM. Most importantly, the name, because we want to work around creative misspellings. And we want the attributes from OSM. That was again bench, shelter, and tactile pavement. We combine the two into an XML file. And we can use the route reference and the stop reference as keys to match them so that they can automatically be merged. Once we have all that, we can actually generate the final printouts. We've decided to use Apache FOP for this, which is an XSL FO renderer. That's XSL formatting objects. It's a page description language, so you might probably be familiar with like HTML for describing markup, or with LaTeX. This is another one in this same league. It uses entirely XML, so we can keep our entire framework XML-based to let us describe elements of a page, how they belong together, and we'll lay out all of this and combine it and produce nice PDF files for us. We produce one A4 page for each stop. Apache FOP as our tool, as I said. So one component that we generate only at this final stage is the strip map, because only now do we have all the information together that we need for it. So we show the previous, current, and subsequent stops in different styles. We get the names, references, and attributes that we have prepared in an XML file, and the correspondences. Each of these bits gets output as XML objects, and FOP renders them for us. We have the overview map that we have generated. We put the overlay on top of it. That lets us produce the final overview map. The close-up map we have as well. We have pre-generated it. And finally, the schedule. We just output a table. FOP can produce tables very easily, and we just write that data into a table. It will lay it out for us. Once we have all these bits, we have a finished A4 page that we can just print, laminate, put up at a bus stop. So all of this works. We have examples of it. We have a working implementation. So the result that we have are printed stop placards that combine the benefits of operator data and OSM data. They are automatically generated, which is really important because very often on the ground, to this date, you will find manual generation and therefore lack of updates. We have a very flexible presentation because we store the data in XML and use all the tools that are available for flexible styling. So our maps are Mapnik, we can use all the tools there, and XSLFO allows us to use XSL style sheets to design the output as we wish. We can style it, we can change fonts, colors, everything. We can even move things on the page very easily. We've also run into a number of challenges, which of course are interesting to anyone doing similar work. An important point for us is OSM consistency. So the data that is tagged in OSM is of course tagged free form. Everyone can use tags as they feel like. Now, public transport is as a field that many people are interested in, and a lot of new experimental things are happening. So if we rely on OSM data to show us where each bus stop is, we will have to have some kind of tag that lets us find those bus stops. So we need to ensure, before we actually produce an update, that the bus stops are all still there. So we must ensure that OSM data is consistent, otherwise we cannot meaningfully combine it with any other data and produce printouts. Another point is OSM completeness. Not only must things be tagged really nice, they must also be there in the first place. So what we found ourselves doing is actually improving the data for Turin especially, which is one of our test regions. We have also done some work in Dublin in Ireland, and we have also done quite a bit of mapping up there to produce better OSM data that we can then use for our generation. Of course, the nice thing here is that once it's in there, we can just keep the data in it. So OSM benefits from that, and we just do the work as part of our generating those placards, and once it's done, it stays. And Apache FOB actually ended up being a bit of a challenge to us because it implements a very versatile standard that's big and complex. And so it does a complex job, and it isn't quite there yet. It implements a decent subset of the standard, but it still has bugs, it has kinks, and it certainly has things that it doesn't fully implement. There's commercial renderers that can be dropped in for FOB, but they cost quite a lot of money, and we haven't experimented with those. Currently, we're just using FOB. It works well enough for us, but we are starting to run into its limitations. So now, in the final slide, I would just like to highlight a little bit of how this can go beyond public transport. So we call this talk custom printed maps, but really a probably better name for it is custom printed documents. Maps are just one of the features. We're using OSM data to produce maps, but we're also using OSM data in other places. The key aspect of our work is that we combine OSM and external data, and the documents we produce are driven by the external data. Whenever that changes and is updated, we can produce new documents, and automatically the newest OSM data is pulled in and produces great results. We can use OSM data combined with that external data for whatever the external data is being applied, public transport being one example. Wherever you think you need a map and you need some other information and you might want to mass produce this Toolchain will be handy. There's benefits to the provider of this external data. We can add maps. There's certainly, as you all know, no licensing cost involved, so that is quite handy. We have a toolchain that is very flexible, so to many external data providers, it might be very handy that they can style it as they wish. They can add more elements to it. They can remove things that they don't need. And OSM benefits from this as well, because, as I discussed on the previous slide, we need to ensure consistency and completeness. So if, say, you wanted to produce bus maps for an entire city, we would need to make sure that all of them are in OSM in the first place. So OSM gets the direct benefit of data being added and updated and kept up to date. And certainly project visibility. If at every bus stop in Vienna, say, you had copyright OSM, that would certainly make you feel good, and that would be excellent. We would love that. And that concludes the talk. So I'll be happy to take any questions.
Thank you very much. Yeah, so do you have questions? There's one.
May you give some details on synchronizing on the consistency of OSM data?
Well, we
some more details. I think about it's very complicated to keep the synchronicity and the consistency of the OSM data. For example, the station naming. In OSM, there are two sides of the station mapped. One on the public transport gives only one point, and so on, and so on.
Right. So certainly what we use right now is the current public transport schema, which is fairly simple. It's not the Oxoma schema or kind of what's developing right now, where you have a stop relation, where you have the stopping point and you have the waiting point and essentially a platform at every bus stop. We don't have that in there right now. What we have is a single node in OSM for the bus stop, like the kind of legacy, if you want to call it, the schema that's been used for a long time. So there isn't the problem of keeping a more complex structure in sync. All you really need is the bus stop node with reference 1, 2, 3 should be there, then we can use it and reference it against 1, 2, 3 in the operator data. Now, once we go on to, say, a big bus station, or once we go on to a more complex schema where we have the platform and we have the stop position individually and maybe the bench even individually, that gets very interesting. So the idea that I believe those new schemas are using as a sort of relation that keeps them together. So at that point, we synchronize against the relation. So rather than looking for our bus stop number 1, 2, 3 as a node, we would look for where is this bus stop 1, 2, 3 as a relation. Once we find it, we find that all the elements in this relation are the ones that belong together. So as long as we can find that, we should be able to easily identify the data that belongs in there. Now, what we have to look out for is, of course, damage to the data. That could happen. So I'm looking for bus stop 1, 2, 3. Oops, it's disappeared. Now, what we can do is in this tool chain, easily, we can check that all the bus stops are there. So basically, before I produce an A4 page, I will try to synchronize stop by stop. And I can clearly halt and say, the OSM data is incomplete at this point, something is missing. And I have lots of options. I can alert the operator and say, there's a mistake, please fix this. That would be great. We want OSM data to get better. Now, if I'm in a hurry, I really want an update, I can just roll back to the last snapshot of my OSM data, the one I used, say, last week, and it was fine. So I can do that. Or I could, I guess, just skip over stop, but that would probably not be nice because you suddenly have nice updated schedules and then there's a stop which is just missing information. But anyway, there is a way to detect it fairly easily, and then we could hopefully just animate the operator to go out and map it.
So what about the license aspects if you combine OSM data with operator data? Is the operator data under the same license, and what about the results? Do you put it under the same license as OSM data?
Right. So, of course, the OGBL hopefully will address some of the issues, because basically what we produce is, in the final result, we have to have compatible licenses. So that the final sheets are do not have to be under CC BYSA. I think only the maps. I'm not quite sure about CC. But anyway, OGBL is supposed to address the idea of combining things where you do not actually derive things from the map data. So there shouldn't be an issue of polluting the operator data. Currently, what we have is actually amazing. In Turin, they have released the entire operator data under a public domain license in GTFS format. So that's like heaven. That's the perfect ideal. You don't get that in any other city I'm aware of. So right now we don't need to worry about it. It's public domain. We can do whatever we want. But the goal here that we really have is working with the public transport operators. So making them aware of the potential, making them give us data under compatible license, making them understand the advantage of having your stops mapped in OSM as well. And so at that point, they should actually feel good about putting the data in OSM. So we've actually achieved something good for OSM as well, and the license becomes compatible because they just release the data to us.
Okay, first it's excellent work. Just a suggestion anymore. Can you have grayed out the bus stops? You've grayed out the bus stops that are passed. Could you also do that on the physical map? Because it's difficult to get the bearing of the bus done on the physical map.
Well, we have it in the overlay map. There we gray them out.
Okay.
Basically, well, sorry. I use KD, I don't use Acrobat. I don't know how to get to that previous page here. Page up, page down. Oh, something's happening. Okay. Well, anyway, while I'm waiting for this to catch up, I'll talk. So, yes, we can grade them out because we upload them by reference and we generate a separate map for every single stop. We can just say if reference, Mapnik uses SQL queries. So we could just have a SQL query that says if map is, if the bus stop ref is in this set, draw it gray. If it's in this set, draw it red. So yes, we can. But on this here, on this picture, you see that there's an overlay. And because the overlay is generated separately, already we're doing exactly that. We're showing them in gray and in red, and that's exactly by a reference number.
Hi, thank you for the brilliant talk. I just wanted to pick up on the same issue of consistency in OSM description and bus stops. It is known that, well, there are at least two opinions on how the bus stops should be mapped, the positions, either nodes of the roadway or the actual location. And I don't have rigorous statistics, but I would actually speculate that there is a considerable amount of bus stops where you cannot unambiguously infer on the direction of travel, for example, regardless on whether the bus stop is a node or just beside the road. Did you come across this issue?
So we have worked, we have done two prototype implementations here. One is for Turin, where every bus stop happens to have a reference number, and if there's a stop with the same name going north and south, they actually have separate numbers. So the issue doesn't exist because we have data that gives us that. And the other one where we have done it is in Dublin, where we have similar data. So we also have separate references for the stops going north and south. I don't have access to operator data from all the cities in the world, so I don't know whether anyone actually has the same stop reference going in both directions. However, it would seem, based on a statistical size here of 2, so that's fairly unscientific, it would seem that for operational reasons you would really want internally to have a reference going one way and the other way. So as long as for internal reasons you have this data, if we work with the public transport operator, even if their references are not normally made public, not printed in their schedules, if they have this data, we can of course feed it back into OSM, providing something nice for OSM, the references that were previously secret. And at that point we can synchronize against them. So we have to make sure that OSM has good data before we can link against it. We do not want to do some hacky heuristic, hoping that if it's closer to the right side of the road, this happens. If it's closer to the left, that happens. That would get nasty. You would get very ugly bus schedules, and we would be back in the field of manual fix-ups, which is what we want to leave behind.
Just a quick remark while we're at that slide. When I first saw it, I actually found the gray points to stand out more, and I thought the bus was traveling north.
Well, certainly the comment here is I'm no graphical designer. I'm certainly just showing what we can do. We were actually, we submitted this to an open data contest, where unfortunately the focus ended up being different and we didn't win anything, too bad. But we were kind of in a rush to get some of the designs out for the contest, so this is me sitting late at night and coming up with colors, and I grant you it's not pretty. One thing that's missing here that I wish I had done it, the half day was missing to do it, was to gray out the route that's actually passed. The whole route is red. That makes no sense. You only want it up to the stop in gray, and from then on red. Certainly something we can do, we just didn't have the time to do it. And yeah, some kind of more subdued color for the stuff that has happened. Maybe an arrow showing you the direction. All those things can easily be done. They're just missing. It's essentially a prototype.
Firstly, I want to say congratulations. That's pretty awesome stuff. How closely are you working with the transit agencies in your two test areas?
So in Turin, we have, well, I don't speak Italian, which is a big problem in Italy, so I wish I had better contacts. We have talked to some local mappers, some people who claim to have a contact with GTT, the local transport operator. Unfortunately, we never got a contact high up, and I'm moving away from Italy in 2 weeks. So I fear that this is a great test region, but we will not, unless someone comes forward and gives us a great contact, we will not be able to make this happen too quickly in Turin. In Ireland, Dermot, with whom I'm doing this work, actually is friends with the public transport operators, so they sit at the pub over a pint of Guinness and discuss this, so it doesn't get much closer.
And just as a comment, you said you weren't aware of another transit agency publishing public domain data. Winnipeg Manitoba, Canada has just published their GTFS data as PDDL.
Excellent.
So that might be your next test
Exactly.
area.
I think you can expect us to roll this out. Of course, one thing that I've mentioned a few times, we need consistency on the ground. So we actually go out and make sure that all the stops are there. I might have to fly to Canada to ensure that.
One reason Winnipeg needs better bus schedules is because if you're waiting there in the winter, it's cold. So
I've seen that in Minnesota. I used to live there. I know what you're talking about.
Are there more questions? Yeah.
Is this a commercial project?
So at the time I submitted this talk, no. By now you've seen the name Dubini show up. That's our company that we're founding in the next week or so. So yes, we are trying to commercialize this because we believe there's space for it. However, we have submitted all the patches we've used to all the open source tools, and so we're trying to be as good citizens as possible. I guess, you know, no crime in trying to earn some money as well like others have, but we hope that we will be able to work with the entire OSM community and make this commercial on top of even better OSM data as it keeps getting better.
So the whole tool chain is open source?
All the components of it are open source. As you can see here, and the slides will be up, of course, on the website, you have Osmosis, you have OSM to PG-SQL, you have Mapnik, obviously, Apache FOP. We're using a few patches here and there, but whatever we use is either it exists already, we've just applied it, or we have made the patches available. Osmosis has already had a release with our patches in it, so everything should be up to date. All the tools that we use are open source. The only thing that isn't is the Python scripts that run it. Oh, please don't forget, I have printouts. If anyone wants to see this printed, forgive me for my bad design, but the idea is on paper, and please grab one.
Okay, so we have 2 more minutes. If anyone has another question. Yeah, there's another one in the front. Yeah.
Hello. Did you consider already to integrate this with other transport information systems? So, for example, I've seen recently this system called One Stop Away from Seattle. It's an open source project for general public transportation. So do you think there might be some connections or some integration possible?
We actually think this is addressing a niche that's kind of there. A lot of stuff is happening online. You're getting your smartphone apps that produce this. In Turin, for example, there's great smartphone apps. There's great information online. You can see when the next bus is coming. None of which is of use to you if you don't happen to have a smartphone. Like, full disclosure, I don't even own a mobile phone. So your grandma might not own a mobile phone. You might not have a data plan. So we think that this is really, for the next 10 years or so, you will certainly still want printed information at the bus stops, and this is something where a lot of the new projects are lacking. They produce great electronic things, but they're missing the printed stuff. So we can absolutely integrate with that, and they provide one thing, we provide the other. Together, we have the full spectrum covered.
Thank you.
Okay, so let's thank the speaker again.